All right, question 2. Just read it. Okay, so we're trying to increase revenue at a business. We have a program that should give 20% of customers a discount in the long run, and they're just worried it's not working correctly. They made a confidence interval of the proportion of bills. And so now let's be clear what this interval means. That means that 0.15 minus 0.06 is 0.09. And if we add it, it would be 0.21. So what they're saying is they found in their confidence interval that anywhere from 9% to 21% are receiving the discount. So just kind of make that clear that that's what that confidence interval means. Okay. A, part 1. Does the interval provide convincing statistical evidence that the program is not working as intended? Okay, I know where this one's going. The answer is no, and that is the interval does contain 0.2 or 20%. So there is not statistically significant evidence the program is working incorrectly. All right, so in other words, if we're trying to say that we don't think 20% is really there, we would have to see an interval where 0.2 was not included. So 0.2 is within this range. For part 2, it says, does the confidence interval provide a convincing evidence that the program generates the probability with 0.2? So in other words, by looking at this data, are you convinced that it is 0.2? This one is, let me read it one more time. 1 and 2 is throwing me off here. Okay, so the answer is also no, and that is since so I'm going to say the interval contains a wide range of data of which is below 0.2. So even though I'm not going to even include, I was trying to link it back to part 1, but I'm just going to not, I'm going to keep it separate. It is generating of the time. I just want to give a clarification because I did actually get part of number 2 wrong. Whoops. So I ended up looking at these sample responses, and so I looked at person B. So they give an answer that's kind of similar to my wording here. They said because 0.2 is on the upper edge of the interval, there isn't evidence that it generates with a probability of 0.2. I kind of said that. And so here's the big idea. When you read this answer, part 2. So there is not convincing evidence. However, the justification is incorrect, and they're basing that on the location of point 2 within the interval. Okay, so it turns out that where you lie in the interval has nothing to do with it. In other words, the interval is there to give you a plausible range of data. So essentially you should just be saying it's incorrect, or in other words, it's no, because the confidence interval gives many other plausible values for the correct proportion that the computer could be generating. Anyways, part B. A second random sample was taken that was 4 times the size of the original. Determine the value of the margin of error based on the second sample that would be used. Okay, so this actually goes back to that confidence interval assignment that I just made. So let's see here. The way they found the first interval was this. We're going to compare that to our new interval, which is 4 times the sample size. Okay, now here's the thing about the math going on here. 4 times the sample size actually means you could write it like that. You could bring the 1/4 out, and you can actually square root 4 roots to 2. You can square root 1 roots to 2, so we get this. So in other words, when we quadruple the sample size, we're actually halving the margin of error. Okay, so part B. We'll say by quadrupling the sample size. I don't think I spelled quadruple right. Oh well. Actually, halving the margin of error given the same level of confidence. So I'll just make it clear what I'm saying. So the second sample confidence interval will have a margin of error half the size of of the, say, margin of error in part A. Just kind of moving quickly here, so I should kind of put more context in there, but because one thing we've always seen in stats, context is key. Okay, last but not least though, based on the margin of error in part B, that was obtained in the sample. What do you conclude about whether the program is working as intended? Okay, well if it is half the size, it is half our interval, and I'll bring some context here. For the true proportion of customer bills receiving a discount is between, well, I guess I'll write it like this, 0.15 plus or minus 0.03, so we halved it, or that's going to be 0.12 to 0.18. Now I'm going to say, since 0.2 is not in the interval, there is significant statistical evidence program is not applying a discount, bringing back in context to 20% of bills as intended. All right, there we go. And now let's score ourselves. So I finished in 13 minutes. Again, that's 2 minutes that I could be going back and adding more context to part B and different things like that, but let's get into it. Wacky question. Part A really makes me feel weird, so hopefully that went well. Okay, so no and no, and so let's see why. No, the interval does contain 0.2, therefore it's plausible. It could be giving a discount in 0.2, and the confidence interval does not provide statistical evidence that the program is not working as intended. So actually, I think I nailed part 1. Part 2 says no. It has intervals from 0.09 to 0.21, so any value in the interval is plausible for the value. Okay, so I think I could have improved my wording on number 2. And I guess that gets at the idea of what a confidence interval is, so I could have answered that a little better. It's the idea that technically anything in that range is a plausible value for what the true answer is. So we definitely, it could be 0.2, but it could also just as easily be any of the other numbers. So any value in the interval is plausible. Now again, I think I'm still technically correct, but we'll see in the precise wording. Okay. So the formula for computing the margin of error includes the square root of the sample size in the denominator. For a random sample that is 4 times the size of the original sample, the margin of error can be determined by dividing the original sample by 2. So I went through the work of showing you that if you quadruple the sample size, you can bring out the 4 in the denominator. It turns out that 1/4 being applied is really 1/2 outside of the root. So the original looked like this. The one with the quadruple looks like half of the original. So that's what that line's saying. So the new margin of error is 0.03. I don't think, did they say to specify what the new margin of error is? Determine the value of the margin error. So I guess I could have specifically said what that is. So again, that's where I was saying I had 2 minutes to go back, read the question, make sure I was answering everything precisely and clearly. Although I did provide the answer right here. Okay, moving on. Part C, there's our interval. It doesn't include 0.2, so there is convincing evidence it's not working as intended. Okay, awesome. So let's read the precise values here. So first one is actually just for part 1A. So did I say because it contains 0.2, it's not convincing evidence? Yes, I did. So I got all my points there. And again, there's lots of partials and things like that. Okay. Section 2, did I respond that it's not convincing and that there are values other than 0.2 in the interval? So I think I technically got it, but I could word that better. Okay, up next, yeah, and again, just make sure you're reading through the wording here. All right, up next, and you know what, maybe we can read the student responses here on this one and see what's going on there. Okay, did you give the correct value 0.03 based on the formula, or by providing correct explanation that recognizes that quadrupling is dividing the original sample size by 2. So I think I got that there. And then section 4 concludes there is significant because that original value isn't contained in the interval. So I think I got that one correct as well. So I really think the only thing I'll change is my wording here in A part 2, and just making sure at the end of the day I say, so then it is 0.03, or it's 0.06 divided by 2, which equals 0.03.